What does it really mean for an AI to think? Today, we're diving deep into Interview Angular. Signals modern Angular interviews are shifting from can you subscribe to can you model reactivity. Signals matter because they make state readable and precise. Understanding signal, computed, and effect is key. Candidates who grasp these concepts can explain why Angular updates correctly. This shows a deep understanding of reactivity in Angular. Notably, signals provide a synchronous and clear way to manage state. Thus, mastering signals is essential for modern Angular development. But here's where it gets interesting. The subscription bottleneck. Old Angular thinking often turns every state problem into an observable problem. Next, this approach works for streams but becomes heavy for simple UI state. Importantly, simple UI state includes counters, filters, and selected tabs. Thus, derived values and local component decisions are also affected. Notably, the bottleneck is not RxJS itself. More specifically, the bottleneck is using stream architecture when direct state suffices. So what's the real problem? Let's talk about the hidden cost of imperative reactivity. Manual subscriptions create invisible responsibility. You must subscribe, unsubscribe, and handle emissions. Preventing leaks and coordinating derived values is essential. Keeping templates synchronized adds to the complexity. The code may look advanced, but the mental model is scattered. Interviews expose this quickly because the real question is not about RxJS. The real question is whether you can choose the right reactive primitive. This raises a critical question. The signal breakthrough. A signal is a state with memory and notification built in. You read it like a function and update it with intent. Let Angular track who depends on it. This changes the interview answer from pushing data into the template to declaring state and letting Angular record dependencies. The UI reacts only where the value is consumed. Notably, this simplifies how data flows in an application. Importantly, it makes dependencies tracking automatic and efficient. Now, let's zoom in on derived state becomes architecture. Computed turns derived state into a first-class design decision. Instead of recalculating values manually, you declare the relationship. Once Angular evaluates computed values lazily and caches the result, it invalidates the result when dependencies change. This is the clean answer for totals, filtered lists, and permissions labels visibility, rules, and any UI value that should never be stored twice. Here's something most people overlook. Effects are not business logic. Effect exists for side effects, not for replacing computed. It reacts when signals it reads change, making it useful for logging. Syncing external APIs and local storage are also common uses. Analytics and imperative browser behavior benefit from it too. The production answer is disciplined. Use signals for state. Computed values handle derivation. Effects touch things outside the model. Think about this for a second. Signal versus observable. Signals represent current state. Observables represent events over time. A selected user, form visibility flag, theme mode, or derived badge count fits signals. WebSocket messages, HTTP streams, debounce search, cancellation, retries, and multi-value async workflows still fit RxJS. Notably, the senior answer is not choosing one winner. Thus, it is drawing the boundary correctly, and this is where things get complex. The bridge between worlds. Modern Angular does not force a rewrite to signal, lets an observable become synchronous reactive state. Next, to observable exposes a signal back into RxJS. Importantly, this bridge matters in real apps, thus HTTP services, router data, and forms often speak RxJS more specifically. The legacy state also relies on RxJS naturally, but here's where it gets interesting. Performance becomes more predictable. Signals make change detection easier to reason about. because dependencies are explicit at read time. Next, combining signals with on-push style thinking improves performance predictability. Importantly, zoneless direction ensures updates only affect dependent parts of the app. Thus, Angular apps become more efficient and easier to optimize. More specifically, the interview signal is confidence in performance explanations. Notably, you can explain performance without vague phrases like Angular handles it. So, what's the real problem? Let's talk about the modern interview answer. The future-ready Angular answer is a layered model. Use signal for writable component state. Computed is used for derived values. Effect handles controlled side effects. RxJS is applied for async streams. Interop APIs are used when boundaries meet. This answer sounds production ready. It shows judgment and technical depth. Modern Angular rewards reactivity design. Notably, it's not just about memorizing subscriptions. Sources include Angular official signals and effects, also ArcGIS interop performance and roadmap docs, Angular 4, Angular 4, Angular 4.